Okay, so this is my AC blower fan uh, with housing, and I think they call it a squirrel cage. So it's my AC furnace fan motor, which I got the whole housing out from my old AC. My old AC was pretty old. I think it lasted me for over 16 years, but eventually there was a leak in the evaporator coil, and it wasn't worth keeping it or repairing it because it used an old refrigerant which is no longer available, maybe R22 or I forget what, but that refrigerant was no longer available and not easy to find in the US. So I just replaced both my ACs with new ones, but the blower fan motor was good the last time I checked when it was working, so I kept that. And now it's a GE motor fan taken from a Carrier AC unit, so I'm gonna test it to make sure that it is in fact okay. um, just because I can someone can use it for their AC, and so it might be good and worth keeping for someone else to use, and possibly sell it on Craigslist or Facebook Marketplace. So now I'm going to test it. I've basically uh, this is the motor itself, and this is the housing with the blower fan. On the other side of it you can see the blower fan inside, and the motor is basically connected to the fan using some there's a spindle, and the spindle is secured to the fan itself on this side, and on the other side there are four bolts where the fan is attached in these four bolts. So anyways, that's what it looks like, and I'm gonna first test it using a multimeter. It's a basic multimeter that I put it on resistance. I'm going to test the resistance between the induction coils, and this is the way most of these motors are set up is there's these two brown wires that are connected to a capacitor, and that's how they're color coded. The white wire is usually the common wire, and then there are three of these colored wires. Basically these colored wires provide three different motor speeds with three different resistances. So the one way to check a motor is to check the resistance between this white common wire and each of these three colored wires for different motor speeds, and basically that should give you three different resistances. If it's short, that's zero resistance, or if it's open, that means that induction coil is bad and the motor is bad. But if you get some value for the resistances, preferably different values, then it means those three different speeds are correct. And there's also some kind of a color coding on what color means what. So let's just get right into it. So first of all, I wanted to show that these use these spade type connectors, and so I didn't really have a female spade connector, and the way it works is the female spade connector is usually on the furnace board, the control board, and this plugs right into the control board. But now we are trying to test it outside of the control board, so we need something to connect this to, and this is, you need a female spade connector, and I don't have one. So what I did is I improvised. I got this picture hanger thing which has a flat piece here, and I pushed that into this. It works like a spade connector, and this is also a connector itself, it's metal. So I wanted to test first to see that it does conduct, So I'm turning on my multimeter. Right now it's an open circuit. 1 means in open circuit, infinity, or whatever you call it. And then using my other LED, I want to first test to see that this picture hanger metal piece does in fact conduct electricity, and you can see it does. It's almost zero. So I'm gonna now test between the common and each of the other leads rather, and then let's see what resistance we get. So the first lead I'm gonna test is the black one, and I'm gonna adjust my stand so that it constantly points down while I do the testing. Stand is harder to adjust, but I'm gonna try to adjust it. So I'm gonna keep it this resting on the stand like this. Yep. And first things first, I'm gonna test for the black lead or the black connector. Let's see how much that shows. So the black connector, the black wire, shows 3.5, 3.4 for the 200 ohm range. So that's 3.4 ohms. 3.4, 3.5, that's what the black shows. Let's next look at the blue. Four 4.2, 4.1, so it's 3.4, 4.0, 3.4, 4.0. Now finally the red. .7. Okay, so that's what the three different resistances represent, three different speeds, and the lower the speed, although the lower the resistance, the higher the speed. So that would mean the black is the high speed, and then the next high speed is the blue, and the third highest speed, or the lowest speed, is the red. And usually in a one-stage furnace you only use one of the speeds, or sometimes the board supports multiple speeds, so you can use each of these as needed. You can use the generally speaking, use the high speed, I think, for AC, and the lowest speed for furnace, but it could be the other way around. So anyway, this was a tutorial. And the other thing to keep in mind is I don't think this resistance test will work if you remove the capacitor, because the capacitor completes the circuit, I think. I could be mistaken. So I want to try to, first of all, you should be very careful. There should be no charge stored in this capacitor, because it could be dangerous. So make sure you don't touch these leads unless you're sure that you've discharged the capacitor, and then you can pull out like these connectors. I'm not able to pull it out right now, but you could pull it out, and you might have to remove the capacitor to do that, so I'll try to do that some other time. Okay, so the second test I'm going to do to test this motor, AC furnace motor from my Carrier AC, is to actually plug it into an AC. It's usually 120 volts, so you can just directly plug it in. The only issue is that the connectors are usually these spade type connectors, and I don't have a female spade type connector, so I've just used a crocodile clip on one, and on the other I've just simply pushed the wire into the space. And for this crocodile tip type of connector, I've used a picture hanger piece, almost like a spade connector, to expose the contact. So hopefully this works, but it's not the safest way. Best is to have a spade connector and crimp it on. And I have this AC wire which I'm going to plug into the AC mains, and I've also wired it to black, which is the lowest resistance, and the other one I wired to white, which is common or neutral, however you want to call it. So if I plug this in, it should engage the motor, and the fan should turn around. The other thing is, I think you do need the capacitor plugged in because it completes the circuit. So I'm going to try this now, but the capacitor will probably hold charge, and you have to be very careful not to touch the capacitor because it's going to hold a very heavy charge. So you'll see what happens when I plug this in, and I have an outlet there which should work. So I'm going to try this now. It should make a humming sound if I plug it in. So I wish I had a switch, but I don't, so I'm just going to plug it in right now. There we go. It is working. This for sure proves that the AC motor is working just fine. Now the thing is, the capacitor is going to have been holding some charge, so it's best not to touch it. Okay, so I'm going to be removing this capacitor because I finished testing this blower motor. I'll keep the capacitor as a spare, and to be able to test my other blower motor when I need to, and before selling this one which is working. And so this usually every blower motor is different and housing is different, but in this case this capacitor is held on the housing by this bracket, and the bracket usually slides into a slot on this side, and on the other side there is a bolt. And so to remove the bolt, I'm using a 1/4 of an inch socket. So this should be pretty easy. Just have to go counterclockwise. Remove this. Now you have to be very careful because this capacitor will probably be holding a charge if you have just used it, so don't touch it with your bare hands. And there you go, I've opened the capacitor now, and you can see that every motor has a different rated capacitor. This is a 7.5 microfarad capacitor. I'm just gonna let it down like this, and I'll use pliers to actually remove the capacitor from the housing. But just to make sure that the unit is still working, all I've done is I've just removed it from the bracket, the capacitor, but so it shouldn't do anything to the unit itself. I would have plugged it in, but it's gonna probably it's gonna vibrate if I plug it in, if it's not secured. I have wired it up, and also I don't want to recharge that capacitor, so I've removed the capacitor, and now I will wait for it to discharge the capacitor before removing the connectors. So that's about it. Okay, so I wanted to test if I can test the resistance of a good furnace fan blower motor without the capacitor. So what I've done is I've disconnected one of the leads of the capacitor, this one of the brown leads from this capacitor, and now I'm going to test the resistances of the various speed motors to see if I can still test blower fan furnace motor without a capacitor connected. So I've actually going to set down this my camera to be able to test the setup. It's kind of hard to do. Actually, I'm going to set it up. It's just a little hard to do, but okay, I'm going to try. Actually, I'm going to get my this is hard to do. Okay, so I'm just gonna hold it up like this, and hopefully this will work. So I have connected one of the leads to this crocodile pin connector. This goes to the white common, and then this one I'm going to connect it to the black high-speed wire over here, and let's see what we get. I have my resistance on the 200 ohms. It's hard to do this with just one hand. Okay, actually I think I figured out the solution. Wipe this. Okay, so I'm going to measure the resistance with the capacitor disconnected, and first one we'll test is the black wire. And so for the black it shows about 3.2 ohms on a 200 ohms range. That's the black. And then, oh boy, my probes are bad. I need new probes. Okay, and then for the blue, oh boy, for the blue it shows 3.8 ohms for the blue, and for the red it shows 4.4 ohms. So it looks like even with the capacitor, one of the capacitor leads disconnected, one is able to test the resistance.